In today's video, we will talk about electric current. Electric current is the rate at which electron flows past a point in a complete electrical circuit. At its most basic, electrical current means the flow of electrons, and the flow of current is electricity, as we know. Just like water in a pipe, it flows through a conductor like a liquid. And electric current is the movement of particles, starting at a moment when external voltage is applied at one end of the conductor. So when a voltage is applied at both ends of the conductor, current flows, and as this current flows, it in turn generates an electric field on the negatively charged electrons that are attracted to the positive terminal of the external voltage. So as we have seen, the flow of current is actually not in the direction of the electrons. It's more like a reaction produced by the movement of the electrons. So a shorter and more precise definition of electric current should be that electric current is a reaction produced by migration of electrons, which as we can see in this diagram here, the direction of flow of current is just opposite to the flow of electrons. And for current to flow, there must be a complete circuit, definitely. This is a example or sample circuit showing the direction of flow of current when a voltage is applied to a resistor, and there is an ammeter there to read it. An ammeter is an instrument used to measure the amount of current flowing in a circuit, and current is measured in amperes. And now let's talk a little about the history so we can understand even how the name amperes came about. Now, the concept of electric current began in the early 1800s. Electrical current was discovered by André Marie Ampère. He was the one who realized that electric current actually means charge transport in 1820. The symbol I, which is the current symbol used today, was used by André Marie Ampère at that time, and the notation traveled from France to Great Britain, where it became standard, although at least one journal did not change from using C to I until 1896. So it's been a very long time since the study of current has started. The discovery of current has been a while ago. Now, we also talk about its uses and importance. Since current is electricity, and we know electricity is important since we use it in our homes every day. It is used to power our businesses and appliances. Electricity in science helps us understand how machines work, and we use this electricity for lighting, heating, cooling, and refrigeration, for operating appliances, computers, electronics, machineries, and public transportation system. Everything we uses current. So everything we do will require electricity, and the flow of current is electricity. The flow of electric current also creates magnetic fields, which are used in motors, generators, inductors, and transformers. A wide variety of fields in which electrical current is involved. Now we'll talk a little about types of current. I'm sure you must have heard the words direct current and alternating current. These are the two basic types of electric current as due to the way they behave in electrical circuit. Well, direct current flows in one direction from the positive terminal to the negative terminal. As you can see the symbol there, it flows from the positive terminal of the battery through the load and back to the negative terminal of the battery. And direct current, as we have seen, is supplied by things like batteries or other kind of direct current power supplies in our homes. whereas alternating current flows in both directions as we use them in transformers and inside our homes. It flows in both directions. It flows to and fro in a conductor, so it actually doesn't really move. It moves to and fro, so the average current in an alternating current circuit is zero, since the electrons don't really move at all. They go to and fro and complete a cycle, and this repeats. So as we see, small appliances like our Arduinos, our sensors, our light bulbs, and other things, you work on direct current, whereas larger appliances like soldering iron, some alternating current motors use AC current. And our homes, we use AC current to power our homes, as it is easily stepped up and down for better control. And I will talk about the properties or the effects in which the flow of electric current has and how we use this to our advantage. The flow of electric current in a circuit exhibits certain effects to the environment. These effects or characteristics that it exhibits are what we harness to produce useful energy for all sorts of work we need it for. And these effects are, as you can see above, heating effect of electric current, magnetic effect, and chemical effect. Now, the heating effect of electric current talks about the amount of heat generated in a conductor when current flows through it. And this heat generated depends on electrical resistance of the conductor. So when a conductor has higher resistance, it makes it difficult for the current to flow, and therefore, like friction, produces heat. And this amount of heat produced also depends on the time. So if the current flows for a longer period, more heat is generated. And the magnetic effect talks about how moving electric charges create a magnetic field which exerts a force on other moving charges and magnetic dipoles. The magnitude of the magnetic field increases as the current increases, like we see in our relays, our electromagnets. As we make current flow through a solenoid, creates a magnetic field which becomes a magnet, a temporary magnet, which is used in making our relays and other things. And our chemical effect talks about how chemical reactions occur when current passes through a conducting solution, like electrolysis. This is a basic separation process in chemistry, very useful. And now we'll talk about some factors that affect the current in a circuit. But there are two important factors that affect the flow of current, which is electricity in a circuit. And as we can see above, there's a resistance and voltage, as seen on the voltage current resistance triangle. And as we have also mentioned just a while ago, the relationship they have has been of great importance to scientific research so far, and their values cannot be derived from one another by mathematical formula which we know as Ohm's law. And this Ohm's law states that the amount of current flowing through a circuit is directly proportional to the voltage applied between the ends of the conductor. And without saying it, you can understand that the current is inversely proportional to the resistance, as it will make it difficult for current to flow, like I shown on the diagram here. On this picture here, you can see Mr. Volt trying to push his current through the pipe, and resistance is reducing the diameter of the pipe, making it difficult for his current to move. And this is the mathematical formula, how current is derived from other quantities. To better understand the concept of electric current, I advise you to watch other videos, study from other sources, and even solve examples. Practice more. Use this cheat sheet as a guide to help you understand the basic formulas and basic approach to solving current related problems using the Kirchhoff's current law and voltage law. This will be really helpful. And thank you for watching. Please subscribe for more.